Welcome back, guys. This is our first unit in what's technically the last unit of the entire school year, which is crazy. But this whole unit is about quadratics. I really enjoyed this unit. I know my opinion doesn't mean much. I'm a math teacher. But I enjoy this unit because it's super challenging in kind of a fun way. It takes so many things we've learned this year and ties it all together into one unit. So it's a challenge. You have to remember a lot. It's going to test you. But like I said, I really enjoy it, so I hope you don't think it's totally miserable. It's kind of a fun way to end the school year. So let's jump right in. Now, two-part lesson. This is part one. Tomorrow's part two. We're graphing quadratics. You've seen that word before. If it's got an x squared, where the highest exponent is 2, we call it a quadratic. Saw that in the polynomials unit. This is also first semester review. If I have to graph something that has an x squared, we did this first semester by making a table. Hopefully this rings a bell. So we made a little t-table, which you can always do if you want to graph. Your first semester teacher probably told you to pick -2, -1, 0, 1, and 2 for x's. And then we just plugged them in for x one at a time to get the y's. When we graphed it, we got a nice picture. So this was in first semester. Before I graph it, let's talk about a couple things we should know. We should know that this graph has a U-shape. It's called a parabola. You've probably heard that word before, hopefully. But if it has an x squared, that's the exponent, the squared. If it has an x squared, it's a U-shape. The x squared makes that happen. This is called a quadratic, like I said. Okay, so if it's got an x squared, I know it's a U-shape, it's a quadratic. U-shape's called a parabola. We know that the parabola opens up in this case. So if you kind of forgot that part, you look at the number in front of the x squared. In this case, it's +2. And since the 2 is a +2, that means that it opens up. If it's a negative number, like on the back here, if there's a negative number in front of the squared term, then it's an upside down U. But this one's just a regular U because it's a +2. So if that happens, and you're looking at a regular U, this means that your parabola has a minimum value. So think about this U right here. The minimum means like the lowest value, the lowest point right here, the lowest point of my U, that would be called the minimum point. Okay, so that's basic things that hopefully we kind of already have in the back of our mind. But let's graph this. Let's do what we did first semester. When you plug a number in for x, so I'm just sticking it right there, you have to use parentheses. So I need to plug it in like that. And if you have the calculator I do, you can just plug it in all at once, parentheses and all. And it'll tell you what your y value is. This first one's 3. I make it easy for myself, and I just arrow up on my calculator and change the -2 to a -1. Same thing. Now I want to plug in 0, so I delete the negative, plug in 0, then I plug in 1, and then I plug in 2. Now I just am looking at 5 ordered pairs. So all you have to do is plot the points and draw them to make your U. So the first point's -2, 3. So left 2, up 3. -1, -3. 0, -5. Okay. First part's review, so I'm going kind of fast. But that would be my U, my parabola. Now, I want to point out a couple things. Realize that a parabola is what's called symmetrical. This means that there's a line that you can draw that cuts the parabola perfectly in half. And this line has a name. This is the first big idea, or kind of like the first big term for the lesson. This line is called the axis of symmetry. Think like x-axis, y-axis, just a line. So that's kind of why they call it an axis. And then symmetry, like I said, That's the line that cuts it in half. Your face is symmetrical. You draw a line through your nose that like divides your face into two equal parts. It's the same idea here. So if I just draw a line, in this case it'd be this one right here with my highlighter, I'm drawing it. And we draw it dashed just to like not make the graph look as messy, and to kind of like distinguish it from the U. So that dashed line, that cuts the parabola into two equal halves. And I kind of cover it up when I do that, something thinner. So if I folded the parabola like on top of each other, it'd be the exact same thing. If I cut it through that point there and drew that line right where it did, that's called the axis of symmetry. Let's label it. First big idea, knowing that the line that cuts the U in half, that's called the axis of symmetry. Okay, let's explore a little bit more about parabolas and graph another one. They tell me to make a table, just like I did on the first one. So I'm going to do the same thing. I'm going to use parentheses. This time I have to plug in x in two places, so be really careful. Use your parentheses, otherwise you will get the wrong answer. I get -3. Arrow up, change both the -2s to -1s. And I get 0. Delete the negatives to type in 0. If I'm going too fast at this part and you need help plugging into your calculator, ask me tomorrow in class and I'd be happy to help you. Okay, so let's plot these points here. Again, this is just 5 ordered pairs, so you're just plotting each one. -2, -3. -1, 0, 0, 5. Whoa, these last two go way off. So 1, 12, 2, 21, way off. Yikes. That looks bad. And I don't know about you, but I don't see the U. I just don't see it. So this is not a U. And I mean, it is. Don't get me wrong. It's an x squared, it's a quadratic. When I graphed this correctly, it should be a nice U shape. But I didn't graph this correctly. The reason I didn't is because I didn't find the middle of the parabola. I'm telling you guys right now, the reason the tables always worked in first semester is because us as math teachers, we picked U's, we picked quadratics that had the axis of symmetry right down the middle of the graph. The axis of symmetry was always along the y-axis. We picked those specifically because you could not handle ones like this. You're a lot smarter now because it's the end of the school year, therefore you should be able to handle graphing ones like this. The big idea though is like the table no longer works because the middle is no longer in the smack dab middle of the coordinate plane. It's going to be shifted around. Maybe the axis of symmetry is over here. Maybe it's over here off to the right. You're going to have to find it. Okay, so realize that the middle of the parabola is where it changes direction. The point at which this occurs, where the direction changes, is called the vertex. That's the second big idea, or big term, vertex. Let's go up and look at our nice U shape at example 1. What they mean by changing direction is like over here, the parabola, it's decreasing, 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 and then, well, right here we shift, and now it's an increasing function. So it goes from decreasing to increasing. This point right here, where it changes what it's doing, that's called the vertex. In this case, it's a minimum point. It's the lowest point of the graph. Okay, you've probably heard that word before, hopefully, but it's basically just like the bottom of the U, or it could be the top of the U. Now, realize that the axis of symmetry, that line, it goes through the vertex. Last big idea. The vertex always lies on that symmetry line, always. Okay, there's two parts of graphing here because today we're just going to do the very first steps of graphing. Tables no longer work. Instead, we have to find the middle of our U. So the first thing we have to do when we graph a quadratic in this unit is we have to find that axis of symmetry line. I gotta figure out where that line is on the coordinate plane. After I do that, I need to find where the vertex lies on that line. So I have to find the coordinates of the vertex. Every U that we gave you in first semester, the vertex was like 0, -5, 0, 3. It was on the y-axis. That's just not the case this time. We have to do a little bit more work. Okay, so like I said, we're just going to do the first steps in setting up a graph today. Part 2, we'll put it all together and actually graph. Okay, I already mentioned this unit's challenging, so it's a lot of information. Take it slow, just takes practice. But there is a formula for finding where this line is. Okay, here's what it looks like. It's a lot of letters, it always is. It's x equals -b, which just means the opposite of b. Means like change the sign. If it's positive, make it negative. Negative, make it positive. So it's the opposite of b over 2 times a. Okay, let's break that down. So notice that the axis of symmetry, it's always a vertical line. And vertical lines are x equals some number. That's why the x equals is there. That's why the formula starts with that. Okay, you don't pay too much attention to that. That just tells me it's a vertical line. The b and the a, though, those come from the general form of a quadratic. So here's where old stuff gets us. Back in polynomials, when we were factoring quadratics, we looked at the general form. Ax squared plus bx plus c. A, b, and c are just numbers. But that's where the b and the a come from in the formula. So since the axis of symmetry goes through the vertex, just keep in mind that when you find the axis of symmetry, that line, you've also found something else. You've found the x value of the vertex. To find the y value of the vertex, you just use your x and you plug it in. That's super wordy. I kind of like to think of it like this. Vertex, guys, it's an ordered pair. It's on the axis of symmetry. So when you find the vertex, it's 2 numbers, the x and the y. The x value of the vertex is whatever you get when you figure out -b over 2a. And that just equals a number. To get the y value of your vertex, you're going to plug the x value in to the function to get the y. So I'm going to say like plug in x for y. Let me show you what I mean by all that. So this is all you're responsible for knowing how to do after this lesson. So it's not as bad as it sounds. It's just like a lot of intro information. But here's a quadratic. I want to find the axis of symmetry. And I want to figure out what are the coordinates, so an ordered pair, of my vertex. Okay, I'm going to use the formula to find the axis of symmetry. And that's all AOS means, axis of symmetry. So the first thing I would do is figure out like what's A, what's B, what's C. So compare this quadratic to the general form. A sits in front of x squared, so in this case it's 2. B would be 8, and C would be 11. So when I do my formula, the x equals is there because that just tells me it's a vertical line, and it's the opposite of b. So b is +8 here, so that means I want to do -8 over 2 times a, which is 2. So that's -8 over 4, which is -2. So the axis of symmetry is the line x equals -2. We don't have to graph this yet, but let me show you if I did, what that kind of gives me a visual of. So the vertical line x equals -2, if you go to -2 on the x-axis right here, that's just the vertical line through that point. That's the line where every single x value is -2. -2, 4, -2, -2. So that's all that means. That's that line. That's the line that cuts the u in half. And I know it's a U shape because there's a positive, so it's a U somewhere on this line. I just don't know where like it has its lowest point. I don't know where the vertex is. It could be all the way down here. It could be all the way up here. I have to find it. So like I said, once you've done the axis of symmetry, you've actually found the x value of the vertex. because you know you want it to be on this line. So you got to go left 2. I just don't know, do I go up? Do I go down? I got to figure out where the y value is. To do that, use your calculator and just plug in -2 in for x, kind of like we were doing on the front when we made tables. And I get 3. So I know the vertex is like -2, 3, and it's a u. From there, tomorrow we'll like talk about how you make it like the u that it should be. Sometimes they're fat, sometimes they're skinny. But for today, that's all we're going to do. Okay, let me do another one. So this one looks weird. It's a binomial, when normally the general form is a trinomial. The x's are missing. That means there's 0 x's. I could like squeeze that in. So guys, a is 5, b is 0. Careful with your signs. C is -8. Don't screw that part up. Identifying A, B, and C. Now when I do the formula for the axis of symmetry, B is just 0. 0 doesn't have a sign, so I don't have to worry about the opposite part. And then 2 times 5 on the bottom, which is 10. 0 divided by anything is 0. So the axis of symmetry is the line x equals 0. To find the vertex, I have the x value. I just have to plug in 0 to find the y value, and it's -8. All right, coming in hot. Asking you for a lot, but see if you can do number 3. There are word problems that come up in this stuff. Makes you apply everything you learned. It's a challenge, but just takes practice. Let me show you kind of what they're asking you to do on this last example. So the situation is a tennis player hits a ball over the net. The ball leaves his racket 0.5 meters above the ground, and this equation, this quadratic, it's got a squared, gives the height in meters at any time, seconds, on like the ball's path. You don't use this 0.5 for anything, guys. They just told you that to show you where this number comes from. All I care about is the formula here. Okay, think about the situation. What direction will this parabola open? Before I do anything else, think about that. I know it's a negative in front of the squared term, so that tells me it's an upside down u. So it looks something like that. So it's going to open down, and I know that because the -4.9, or that's the a value, it's negative. If you think about the tennis player situation, that makes sense. Feast your eyes on my lovely drawing here. Okay, 2 people playing tennis. Here's the net. Why do I suck so bad at art? That could have been worse. Could have been better, but it could have been worse. All right, this dude, here's a tennis ball. It's 1/2 meter off the ground when he hits it, so he's going to hit it over the net. There you go, guys. Upside down U. So it's a parabola. The path of the ball is a parabola. That makes perfect sense. This formula gives me how high the ball is after so many seconds. Okay, realize that if it's an upside down U like this, now the parabola has a maximum point. When it was a U, it had a minimum, like the lowest point. This one is upside down, so it's going to have a point where it's at, like, the ball's at its highest point. That's right there. It's a maximum. And that's what the question is going to be asking me about. When will the ball reach the highest point? That word highest right there is my cue that I'm finding the maximum point. I want to know how many seconds is it going to take the ball to reach this highest point. If they're talking about the highest point or the lowest point, that's the vertex. The vertex is either the max or the min of the parabola. I know, guys, that the vertex is an ordered pair. It's 2 numbers. That's why they're asking me 2 different questions. Okay, normally it's x and y. In this case, they're using t instead of x, and they're using h instead of y. T just stands for the time, and h is the height. So if they say when, they want how much time does it take for the ball to reach this point right here. I just want the x value of the vertex, which is what I just did right here. And to find the x value of the vertex, I just did the axis of symmetry. I used this formula. So it's kind of like a lot of words and stuff, but it's the same thing you just did. It's you just figuring out that, oh, all I have to do is the axis of symmetry. So check it out. It's the opposite of b. b is 3.8, so I do negative 3.8 over 2 times a. On the bottom, you should multiply first, so that's negative 9.8, and then do your division. You are answering a time question right now, so if you get a negative number, that makes no sense. They didn't tell me how to round, so I'm just going to say 0.39 seconds, which makes sense. It wouldn't take very long after the ball's hit to reach that highest point. Then they asked me, okay, well, how high was the ball? I want to know the height after that time. So I have the time it takes. I want the height that goes with it. So all I do is what I did up here. I'm just going to plug in 0.39 for time to figure out the height that goes with it. So let your calculator do the work. I'm just plugging in 0.39 for t. And I get about 1.24 meters.